All right, hello everyone. So this is the solution to the Edexcel IAL January 2017 S1 paper. Now let's start with question 1. Ralph records the weights in grams of 100 tomatoes. So 100 is our total number of tomatoes or the total number of items, which we usually denote as N. And this information is displayed in the histogram below. Given that 5 of the tomatoes have a weight between 2 and 3 grams, so 5 is the total number of tomatoes between 2 and 3 grams. So it's the frequency of this class, of this histogram bar. Find the number of tomatoes with a weight between 0 and 2 grams. So we need to find the frequency of this bar or this class. All right. So for this, we need to use the fundamental property of histograms is for histogram bars, the frequency is proportional to the area or is equal to some fixed constant multiplied by the area. All right. So we can rewrite this equation a bit. The histogram bars, they're all rectangles. So the area is just equal to the width multiplied by the height. Now, let's put a scaling on the vertical axis so that we can work with it. Now, this is just based on our choice. I've put every big square as 5 units, okay, like 5, 10, 15. You could do 1, 2, 3, or any other appropriate scaling. Any scaling works, but it's just up to our choice. We'd really get the same answer at the end. Now let's work with the class that we know the information of. So for W between 2 and 3, the frequency, that's 5, it's given as 5, is equal to K multiplied by the area. Now the area is the width multiplied by the height. So for this class, as we can see, the width is 1 unit and the height is exactly 5 units here. The height is exactly 5 units according to our vertical scaling. And so this gives a value of k is equal to 1. So this means that since k is equal to 1, the frequency is exactly equal to the area. All right. Now, uh, for the class that we need to find the information of, the width is 2 units, like here, and the height is also 2 units. So we can find the frequency of that class. So for W between 0 and 2, the frequency is equal to the width multiplied by height, basically the area. So that's 2 into 2, and that is equal to 4. One of the tomatoes is selected at random. Find the probability that it weighs more than 3 grams. All right. So the probability of the weight being more than 3 grams is naturally 1 minus the probability of the weight being less than 3 grams, or between 0 and 3 grams. 0 is the minimum weight. Weight cannot be negative. All right. So because this is these two are complementary events. These two are complementary events. That's why their sum has to be 1, or one of them is 1 minus the sum, 1 minus the other. All right. So now, the probability of the weight being between 0 and 3 grams is 4 plus 5 divided by 100, because we need to consider the total frequency, the cumulative frequency from 0 to 3. So there are two classes there. There's from 0 to 2, there's one class, and the frequency of that is 4, as we found in the previous part. And the other one, from 2 to 3, the frequency of that is 5, as was given in the previous part. So this is the total number of tomatoes that have a weight between 0 and 3 grams. And this is divided by, to find the probability, this is divided by the total number of tomatoes, which is 100. All right. And if we evaluate this, what we get as an answer is 0.94. Next part, part C. Estimate the proportion of the tomatoes with a weight greater than 6.25 grams. All right. So, for the tomatoes with a weight of greater than or equal to 6.25 grams and less than 10, because 10 is the maximum weight in the histogram. So first we need to find the number of tomatoes in this interval and then divided by the total number, which is 100, to find the proportion or the probability. All right. So first, let's take that histogram as reference. Now, to go from 6.25 to 10, we need to divide the interval into portions. So here, I've divided it like this: 6.25 from 6.25 to 7, so somewhere here, and from 7 to 8, this is that whole bar. From 8 to 9, this is that whole bar, and from 9 to 10, this is this bar. All right. Now, the number of tomatoes in each of these intervals from 6.25 to 7, it's not this whole bar. However, the frequency of this interval will still be equal to the width of the interval, which is 0.25, which we can see very easily: 7 minus 6.25 multiplied by the height here. The height here, as you can see, is 16. So the formula which we found in part A still applies here. The frequency will be equal to the area. Okay. Uh, that added with the frequency of the next bar from 7 to 8. So it's the width is 1, the height is 25. Next bar, the width is 1, the height is 10. Next bar, the width is 1, the height is 8. So like this, we are adding up all the frequencies to find the total frequency here, which is 55. Now, the proportion is going to be 55 divided by the total number of tomatoes, and that is 55 by 100, which equals 11 by 20. Using your answer to part C, explain whether or not the median is greater than 6.25 grams. Now, 55% of the data lies in W is greater than 6.25. Why? Because we just found that the proportion of tomatoes with a weight greater than 6.25 is 0.55 or 55%. All right. So 6.25 grams is the 45th percentile. If 55% of the data lies beyond this point, so 45% lies in or to the left of this or below this, so this must be by definition the 45th percentile. This is by definition the 45th percentile. But the median is the 50th percentile by definition. So the median is a bit to the right or a bit above this 45th percentile value that we found, value of 6.25 grams. So the median definitely exceeds 6.25 grams. This is the 50th percentile. It definitely would exceed the 45th percentile. All right. Given that the mean weight of these tomatoes is 6.25 grams, and using your answer to part D, describe the skewness of the distribution of the weights of these tomatoes. Give a reason for your answer. All right. So the mean is 6.25 grams, and we found that the median exceeds 6.25 grams. So, in other words, the median exceeds the mean. And if that happens, we know that the data is negatively skewed. All right. Next part. 2 of these 100 tomatoes are selected at random. Estimate the probability that both tomatoes weigh within 0.75 grams of the mean. So within 0.75 grams of the mean. So first, let's find the lower and upper bound. So 6.25, that's the mean. Minus 0.75, we get 5.5. Plus 0.75, we get 7. So the tomato weighing within 0.75 grams of the mean means that it's within this interval, 5.5 to 7. All right. Now, the number of tomatoes within this interval is going to be 1.5 multiplied by 16. Why? Because the width is 1.5 and the frequency density of the class from W going from 5 to 7 is 16. So we're taking that frequency density, and this interval is within this class. So we can just take that frequency density. It applies to this interval also. So the width multiplied by the frequency density or the height, and what we get as the answer is 24. All right. So the probability of being in this interval is, well, we are taking 2 tomatoes. We're picking 2 tomatoes. It's not told whether there's replacement or not. But by default, if there's nothing mentioned, we should assume that there's no replacement. So first, we're taking a tomato from this group. So there's A 24 out of 100 chance, 100 is the total number, all right, and that's multiplied by, so we're picking another tomato, but now we have one less tomato that's within this interval, and also we have one less tomato from the total number of tomatoes because there's no replacement. So the second probability is 23 by 99. So multiplying these two, what we get as the final answer is 46 by 825.